Let's talk about standing waves today. Standing waves are waves that appear to be staying in one place. You'll see what I mean. We're going to cause this string to vibrate. So we have a string here which is attached at each end. That's important. So each end needs to be what we call a node. Why? Well, because it can't move there. It's attached. So I'm going to drive this string using a frequency driver, and it's going to create a small disturbance. And we're going to see what happens as we change the frequencies, and we'll see if we can get some standing waves happening. So I'm going to start at a low frequency, and I'm going to increase the frequency until I get a standing wave. So I'm going to start at 1 cycle per second. Okay, so what's happening? The wave is generated, goes down, bounces off the other end, and then comes back. Okay, well that's not very interesting. Let's increase the frequency. So that is 1 hertz, or 1 cycle per second. Let's put it at 2. Okay, now we're at 2 cycles per second, and I don't see any sort of organized pattern happening here. I'm sending waves down, they're bouncing back, they're interfering with each other as the wave heads down and then bounce back. As they meet, they interfere with each other. Let's try increasing the frequency again. Now we're at 3 hertz, 3 cycles per second. Well, these things are almost destructively interfering with each other all the way along. We're really not seeing any kind of standing wave whatsoever. Let's now go to around 4 hertz. Oh, look what just happened. We're sending a small wave down. It reflects off the other end and comes back. And notice what happens right here in the middle. Right in the middle, we have an antinode. We have an area where there's maximum deflection up and down. Okay, so what happens if we increase the frequency more? Let's go to 6 hertz. Whoa, 6. Okay, so at about 6 hertz, well, there's no standing wave pattern. Let's go to 8. Oh, look at that. Now we have another standing wave pattern. We have a node right in the middle this time. So we have a node, 2, 3 nodes. We have 3 nodes. We have 1, 2 antinodes. Let's increase the frequency again. So let's go to 10 hertz. Oh, our standing wave pattern has disappeared, as you can see. Let's go to about 12 hertz. Oh, 12. I went past it. And right about there. Now you should be able to see we have a node, 1, 2, 3, 4 nodes. 1, 2, 3 antinodes. Let's try one more. Let's see if we can get it even further. I've noticed a pattern here, so I'm going to go up to where I think the next standing wave is possible. You should have noticed that we didn't get standing waves at every possible frequency. It only happens at certain frequencies. And the standing waves only occur at certain frequencies based on what we call the boundary conditions. We have a node at each end. And there's only certain frequencies which will generate standing waves in this medium. So how many nodes do we have now? One at each end. So 1, 2, 3, 4, 5 nodes. How many antinodes do we have? 1, 2, 3, 4. So we managed to generate another antinode, another standing wave. And we could increase the frequency even more. And, increase the frequency until we get the next standing wave. Now, the speed of my wave in here stays constant. Why? Because the speed depends only on the medium, so that's something to remember. And I keep the tension constant, and I keep the tension constant because I have a mass hanging here. If I change the speed of the wave, my standing wave goes away. But since my speed of my wave is constant, because of the mass I put here, I end up with the next standing wave pattern. And this can just keep going and going and going.